For today's video, we will answer the question of one of our followers. Can you prove the Heron's formula? And here's my response. Alright, so let's prove the Heron's formula. So we have the area of this triangle must be equal to the square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c. So let's begin. First, what we're going to do is to drop a perpendicular line coming from this vertex B. And let's call this as H. Now take note, the area of this triangle must be equal to 1/2 times base times height, or simply equal to base times height divided by 2. Now, our goal in this question is to replace this H in terms of side A, side B, and side C. Now, to do that, let's call this segment be equal to x and this segment be equal to y. And now take note, x plus y must be equal to our side B. Now, using this right triangle right over here, let's use the Pythagorean theorem. So if we do that, we get x squared plus h squared equals a squared. And using the second right triangle, using the Pythagorean theorem again, we have y squared plus h squared equals c squared. And take note that our goal is to replace this variable h, or the height, in terms of side A, side B, or side C. Now, what we're going to do is to eliminate this h squared, and to do that, let's subtract these two equations. And if we do that, we get x squared minus y squared equals a squared minus c squared. And now let's focus on this result. Now, x squared minus y squared, this is just x plus y multiplied by x minus y. So we can factor out x squared minus y squared into x plus y multiplied by x minus y. Because we know the value of x plus y, this is just b. So we can replace this factor as b. Now, divide both sides by b. And we get that x minus y equals a squared minus c squared over b. And also take note that x plus y equals b. So we can now solve for the value of this variable x. So to do that, let's have these two equations and let's add these two equations. Because if we add this, we eliminate this variable y. This is just 0. So we have 2x on the left-hand side equals a squared minus c squared over b plus b. Now let's combine this. We can write this b as b squared over b. So we have the same denominator. We can combine them, add the numerator, and copy the denominator. Now, we can now solve for the value of x. Let's divide both sides by 2. And there you go. We have the value of x. But to replace h in terms of a, b, c, side A, side B, side C, we need x squared. So let's square on both sides. Now, let's get this equation. And now let's go back to this right triangle. So because using the Pythagorean theorem a while ago, we get x squared plus h squared equals a squared. We can now solve for the value of h squared. So subtract x squared on both sides. We know the value of this x squared. This is just this expression right over here. So we can replace x squared by this equivalent. And there you go. We have the value of h squared. But we want just h. So just get the square root on both sides. Take note that h is positive, so we don't care the negative value for h. Alright. Now, we have here the area, base times height divided by 2. We can write this also as b over 2 times h because we will replace this h by its equivalent in terms of side A, side B, side C. Now, let's focus on this. We have the area of this triangle must be equal to b over 2 multiplied by the square root of a squared minus c squared plus b squared all over 2b raised to the power of 2. Whew. We are now not yet close to the Heron's formula. S multiplied by s minus a multiplied by s minus b multiplied by s minus c. But we will get to that point later on. Alright. So first, what we're going to do is to rearrange some terms a little bit. to make this looks nice. And then we can simplify this expression as follows. We have a squared plus b squared minus c squared raised to the power of 2 over 4b squared. Now, let's combine these two terms. So, let's rewrite a squared by 4a squared b squared over 4b squared to have the same denominator. So, we can combine them. Next, we can also pull out this 4b squared because it's a perfect square. So, if we do that, we have 1 over 2b. And if we do, we eliminate this variable b. B and b cancel out. This is just 1. And 1/2 multiplied by 1/2. This is just 1 over 4. Alright, now let's focus on the expression inside the radical sign. So this 4, we can rewrite this as 2 raised to the power of 2. And 2 squared times a squared times b squared, we can simplify this as 2ab raised to the power of 2. Now, we have a square number minus another square number, so we can use the difference of 2 squared. Because we can factor this out as follows, m plus n multiplied by m minus n. So, we can factor this as follows. We have 2a plus a squared plus b squared minus c squared multiplied by 2ab minus we have a squared minus b squared plus c squared. Now, let's focus on this expression. We have 2ab plus a squared plus b squared minus c squared. Now, let's rearrange some terms a little bit. And this expression looks nice because we can factor this out because this is a perfect square trinomial. We can factor this out as follows. We have a plus b raised to the power of 2. Again, a square number minus a square number. So we can use the difference of 2 squares. And if we do that, if we factor this out, we get a plus b plus c multiplied by a plus b minus c. So we can replace this expression with this equivalent, like this. And now we will do the same thing on this expression. Let's get this. Let's focus on this expression rather. And let's rearrange some terms a little bit. Now, let's move this positive 2ab between a squared and b squared. Let's factor out the negative 1. If we do that, we have negative of a squared minus 2ab plus b squared. And again, this is a perfect square trinomial. And we can factor this out as a minus b raised to the power of 2. Again, a square number minus a square number. So we can use the difference of 2 squares. And if we factor this out, we get c plus a minus b multiplied by c minus a plus b. So we can replace this expression with its equivalent. Now, we're almost there. So let's put this 1 over 4 inside the radical sign. So this becomes 1 over 16. And we can write this as all over 16. Now this 16, this is just 2 times 2 times 2. Now since we have 1, 2, 3, 4 factors, let's distribute these 2 in those factors like this. And now, for the moment of truth, let S be equal to a plus b plus c all over 2, or the semi-perimeter. And what is the value of S minus a? So S is a plus b plus c all over 2, then minus a. So let's combine this. So this a, we can write this as 2a over 2. And we can now combine these two fractions. Now a minus 2a, this is just negative a. So S minus a is just b plus c minus a all over 2. Now how about S minus b? Again, we will do the same thing. Let's combine this. And b minus b is just negative b. And for the last one, S minus c, the value of this, if we simplify this, we get a plus b minus c all over 2. And take a look at this one. Notice we can rewrite this c minus a plus b as c plus b minus a. So this looks like this. This looks like this. This looks like this. And this looks like this. So this expression is just s. We can replace this with x. And this expression right over here, this is just S minus C. And this expression, we know this is just S minus B. And the last one is S minus A. So, we have S multiplied by S minus C times S minus B times S minus A. But we can interchange this C and A because this is just a multiplication. So, 3 times 4 is the same thing as 4 times 3. Alright? So, we can replace this. We can interchange this. And there you have it. This is the Heron's formula, wherein S is just the semi-perimeter, or A plus B plus C divided by 2. And there you go. The derivation or the proof of the Heron's formula. And as always, we are done.